All right. I hope everyone is able to see the screen and to hear my voice. Okay, so let's continue. So first of all, I'll start by defining what makes up a complex number. Okay. So when we talk about complex numbers, these are simply just imaginary numbers. So when you have a number that has okay, sorry for that. Okay, so the square root of any negative number, is considered to be undefined, but after learning complex numbers, we'll know what that means, and we'll be able to find the solution of any square root of negative numbers. Now, for instance, if you have the square root of negative 25, we all know that the square root of 25 is 5. But every time you came across the square root of negative 25, you always said this is undefined or it has no solutions. But after learning complex numbers, you know what this means, and you'll be able to find the solution. Yeah. So any number that is in the form, yeah. So usually a complex number, complex numbers are denoted by Z. Yeah. So every time you find any number that is in the format A plus IB, where this A is called the real part of a complex number, and then this part here, which contains the I, is the one that we call the imaginary part of a complex number Z. Okay. So I'm sure you've all seen this I before. Yeah, so this one is different from the one that you see in vectors. Yeah. So this I is simply just equal to the square root of -1. Yeah, so this is what usually helps us to find the square root of any negative any negative number. Yeah, for instance, if you have the square root, like the example I gave, if you have the square root of -25, so the square root of -25 can also be written as the square root of -1 times 25. Okay. So this can be simplified further. We can write this as the square root of -1 times the square root of 25. But remember what we said? We said the square root of -1 is equal to what? I. So where there's the square root of -1, we can just replace that part with I. And then this other part, we know the square root of 25 is simply just 5. Okay. All right, so 5 times I, this will give us 5I. So this tells us to say the square root of -25 is simply just going to be 5I. Yeah, so this is one of the importance of complex numbers. So it helps you to find the square roots of negative numbers. So now let's look at this. So we said this. We said I is simply just equal to the root of -1. And then what if we say I squared? So what could be the solution here? Or what's the solution? What's the answer for I squared? So I squared is simply just the same as the square root of -1 and then squared. So what this means is that we have the square root of -1 times the square root of -1. And when you multiply these two, the answer that you're going to get will simply just be -1. So other people would say this square root and that squared there will cancel. So you just remain with what? -1 there. And what if we say I to the power 3? What does this, what's the meaning of this? So I to the power 3 is simply just the same as the square root of -1 times the square root of -1 times the square root of -1. So remember we said the square root of -1 times the square root of -1 gives us what? -1. And then the square root of -1, we said this is equal to what? I. So this is just the same as multiplying -1 and I. So when you multiply this, you get -I. And hence, I to the power 3, the answer is -I. Okay. All right, so this is exactly what you're supposed to do. All right, so let's quickly see what we have. Okay, so by definition, I mean the definition of the SAD, okay, I think I've explained all this. Let me just skip that. I've talked about everything here. Okay, so I also talked about the real part of the complex number and the complex part of the complex number, or the imaginary part. Okay, let's see how you add and subtract complex numbers. So we're going to look at how you add, subtract, multiply, and divide complex numbers. Okay. And before we do that, let's talk about equal complex numbers. So if I say I have Z1 or Z1 and Z2. So if you have these two complex numbers, we have A plus IB, and you also have X plus IY. If we say Z1 is equal to Z2, if we say that these two complex numbers are equal, it means that A is equal to what? X, meaning the real part of Z1 and the real part of Z2, the answer, these two parts are simply equal. Then it also applies on the imaginary part. So this tells us to say, even this imaginary part of Z1 and the imaginary part of Z2, they are also what? They are also equal. In other words, we say IB is equal to what? IY. So don't be surprised if you open a book and you find, while there's I here, you find J. Yeah, so there are some books which use J instead of I. Still means the same. Okay. You have a question? All right, I was trying to mute everyone. Okay, so let's proceed. So let's take a look at this example. So I've explained this. So example 1, this is asking us to find the values of A and B, for which 2A plus 3I is equal to 6 minus IB. So remember what I said, if you have two complex numbers which are equal, it means that the imaginary part there will be equal to the imaginary part on the right, and then the real part on the left will be equal to the real part on the right. Okay, so let us equate those. So you have 2A being equal to this real part there, because we have the real part on the left is 2A, then on the right we have 6. So we can just divide both sides by 2. so that we get our A to be equal to 3. So we do this the same even for the imaginary parts. So we have 3i being equal to negative ib. So you can see that if we divide by I on both sides, we divide by I this divided by that, this divided by that, you get 3 being equal to negative b. And if you divide by negative 1 on both sides, you're getting b being equal to what? Negative 3. So these are the two solutions that they are asking us to find. Okay, so let's look at how we can add complex numbers. So let's say, for instance, you have Z1 as a complex number, and it has A plus IB. Then you also have Z2, which has X plus IY. Then you've been taught to add Z1 and Z2. So when adding these two complex numbers, you simply just add the real part to the real part, and then the imaginary to the imaginary. So in other words, I'm trying to say you add A plus IB, then you say plus. Z2 there is X plus IY. Okay, so this is what you have. So you're going to add this part and that part. And this is going to be A plus what? X. Put them in brackets. Then you say plus. Now open brackets, you have B plus Y. Or if you want, you can even say IB, then plus. Have IB plus IY. So you have the solution as A plus X in brackets, then plus B plus Y when we factor out the I. Okay. So this is what you have as two complex numbers being added. All right, so let us take a practical example. We have Z1, which is 2 plus 3i. Then you have Z2, which is maybe 4 plus 6i. Then you've been taught to add these two complex numbers, Z1 plus Z2. So how do you do the addition? So, okay, let me add them using this space down. So we have Z1 plus Z2, and this is going to be equal to, we add this to that. So we have 2 plus 3i. Then we're saying this is being added to 4 plus 6i. So remember what I said, you pair the like terms together, meaning we're adding the real part to the real part there. So we have 2 plus 4. And then you also have the complex part to the complex part there. So you have plus 3i plus 6i. So when you do the addition here, you're going to have 2 plus 4, and this will give you, this will give you what? 2 plus 4, this will give you 6. Then you also have 3 plus 6. So when you add these two, you're going to get 9. And because that's an imaginary part, so we have to include the I. Okay. So this is the solution to the first example that I've given. So I've talked about all this. And then subtraction of complex numbers, we do the same. If you have Z1 as A plus BI, then you have Z2 as X plus YI. When you've been told to subtract Z1 from Z2, so that is Z2 minus Z1. This means that you are going to subtract this from that. And we're going to say X minus, so in short, we're just subtracting the real part from the real part, and then the imaginary from the imaginary. So we have X minus A. And then we say plus, we also have this minus that. So we have Y minus B. Yeah, so this is what we have. So now let's take a look at some practical examples. Yeah, so we have Z1 as 2 plus 3i. Then we have Z2 as Z2 as 4 plus 6i. Yeah, so subtracting Z1 from Z2. Yeah, so subtracting Z1 from Z2, we're going to have this 4 minus 2 there. So it says Z2 minus Z1. We have 4 minus 2. I'm subtracting the real, this real part here from this other real part. Then we say plus. Then we have 6 minus 3. So when you do the subtraction there, we have 2i, then plus 3. Oh, sorry, we have 2 plus 3i. Okay. So this is what you get as the solution. All right, so let's quickly move on. So let's.
Hello.
Yes, sir.
Yeah, I just to take you behind a bit.
Yeah.
Can it be asked like maybe to subtract from Z1 instead of Z2?
Yes, it's still the same. So
Okay.
yes, our Z1 was it 3? I just wrote a random. Okay, let me just get other numbers. So we have 3 plus 4i, then Z2, we say maybe 4 plus 6i.
Yeah.
Yeah, so
Yes.
the question was, can we be asked to subtract Z2 from Z1?
From 1.
Yes,
Yeah.
the answer is yes. So we can say Z1 minus Z2 is equal to, so we're going to say Z1 here, on the real part of Z1, we have 3 there. Then on the real part of Z2, we have 4. Then the real part of Z1, I mean the imaginary part of Z1, we have 4i. Then the imaginary part of Z2, we have 6i. Okay, so this is what we have. So when you subtract the first part here, 3 minus 4, the answer is -1. Subtract the second part, you have 4i minus 6i, the answer is -2i. So this is what you're going to get as a solution.
Thank you.
Welcome, sir. Okay, so let's take a look at how we can multiply complex numbers. So, okay. Let me just use examples to, to explain this. So if you have Z1, which is equal to, let's say 1 plus 2i, then you also have Z2, which is equal to 2 plus 3i. So whenever you're multiplying complex numbers, the most important thing that you have to put in mind is the I. So you have to know that I times I will give you what? -1. I explained this when we just began. You also have to know that I to the power 3 will give you what? -i. And the most important of all, you have to know that I is simply just equal to the square root of -1. All right, so from what I've written here, we can multiply complex numbers. Okay, so we have these two examples here, Z1 and Z2. So if they say we multiply Z1 and Z2, the answer that we're going to get to be 1. Okay, let me first write them here. So we have 1 plus 2i, and then we're multiplying this with 2 plus 3i. So when you do the multiplication here, you have something like this. So you do the normal multiplication of two, the same way we multiply two functions. For instance, if you have x plus y there, then you're multiplying it to maybe 2 plus x. Let me just say x plus x squared plus 1. Well, let me even remove a squared. X plus 1, you're multiplying it with 2 plus x. The same way you multiply these two numbers there, or two functions, the same way you multiply complex numbers. But you have to put in mind that I is equal to the square root of -1, and I times I will give you what? -1. Okay, so let's do the multiplication. So here we're going to say this one should multiply everything in the next brackets there. So we have 1 times, we have 2 plus 3i. Then from there, we also say this +2. So we say, we write +2 there, positive 2i. We'll also multiply with everything that is, that are in these brackets. Okay, so we have 2 plus 3i in the brackets. So 1 times 2, the answer is what? 2. 1 times 3i, the answer is 3i. Then we have 2i times 2 there. This will give us positive 4i. So now the last part here, this is why a lot of people get confused. And this is why most of the people get it wrong. Okay, so when you multiply 2i times 3i, when I say 2i times 3i, you are simply multiplying 2 times 3, and that will give you what? 6. Then you are also multiplying I times I. But remember what I said, when you multiply I times I, we're getting what? I squared. And I squared, we said I squared is simply just equal to what? -1, because I squared is the same as I times I. So this is just the same as multiplying 6 times -1, and this gives you what? -6. Okay, so we can put our -6 here. So we add what we have in common there. So we have 2 and -6, we can put them together. Then we say positive 3i and positive 4i. We also put them together. Then from there, we can just simplify the expression. So we have 2 minus 6, the answer is -4. And then 3i and 4i, when added, they will give us what? 7i. So this is how simple it is, multiplying complex numbers. Okay, do we have any questions before I can move on? Before I can change the slide? All right, so we move on. Okay, let's take a look at some examples. I think I explained all this. Okay, we have this example here. So we have these two complex numbers being added. We have 3 plus 2i, then plus 4 minus 6i. So when you add these two complex numbers, you're simply just adding the real parts together. So we have 3 and 4 there. When you add them, you're going to have 3 plus 4. Then from there, we write this plus there, write it in between here. Then we open another set of brackets. So we say 2i and -6i, we put them in that in these same brackets. So we have 2i and -6i. So 3 plus 4, the answer is simply 7. Then we have 2i and -6i. When you add them, you get -4i. So this is the solution. So we also have these numbers that we need to have to assist. Yeah, the numbers that we have to add. So we just take the like terms, we put them together. So we have these two, we also have this one there. When we put these together, we're going to have 2 and +1 in brackets. And you also have the square root of 2i and this i there. So you have plus I root 2 and also I. Okay, so when you add 2 and 1, you are getting 3. Then when you add these two, because we have an irrational number here, which is the root of 2, then we also have the root of 2 here, and this one is just the normal I. So adding these two is practically impossible. So we can just factor out the I so that we have the root of 2, then plus 1 in brackets, then we put the I outside. So this is the solution. Okay. So let's quickly move on.
Hello.
Yes, sir.
So we can't leave it like I to the square root, I the square root of 2 plus I. It can't be left like that unless it's simplified like the way you've left it.
Okay. You can also leave it like this, but it depends with the marker. Some of them might deduct some marks. So this is just the same as leaving a fraction in an improper, leaving a fraction in an improper form, or maybe,
Perform all right.
yeah, just the same as also maybe leaving a fraction in this form. Let's say, for instance, you have 8 over 16, then you decide to leave your answer in this form. Yeah, some of them would consider that maybe to be, I don't know, they can't give you full marks, in short. Yeah, so you always
Thank you.
have to simplify the solution as, yeah. Okay, so let's quickly move on. Okay, so we're just from discussing how we can add complex numbers. Let us see how we can, let us see now, let us take some examples and see how we can subtract them. Okay. I'm sure I've explained everything here. I think there's no need for me to explain anything. So if we subtract, let's say we've been asked to subtract Z1 from Z2. Z2 minus Z1, this will give us what? So Z2 here we have is negative 7i, then we say minus Z1. Our Z1 is negative 10 minus 3i. So make sure that as you are replacing these complex numbers, you're always putting them in brackets. Yeah, it helps. Okay, so we can now remove the brackets. So we have this is 7i, then negative times negative 10 there will give us what? Positive 10. Negative times negative 3i. This will give us positive 3i. So here's just a matter of putting the like terms together. We have negative 7i and 3i there, which will give us negative 4i. Then we have plus 10 there. So we can just write this as 10 minus 4i. So do we have any questions on how we can add and subtract complex numbers? Okay. So multiplying complex numbers, I think I've talked about this. Yeah, so I'm going to give you this part for multiplication as an exercise. Yeah, because multiplication also involves subtraction and addition of complex numbers. So you can do part A, B, and C. Then when you finish solving, you can simply just send the solutions using my WhatsApp line. Yeah, so you can just forward your solutions, and then I'll check them out, then correct you where I'm going to be wrong. Okay, so you should do part A. Okay, let me do part A, and then you do B and C as an exercise. Okay, so we have negative 4 minus I in brackets. It's multiplying with 6 minus 2i. So multiplying this is just done in a similar way, or let me say in the same way. You multiply other functions. So we have this negative 4 multiplying with everything in the brackets this side. So we have 6 minus 2i. Then from there, we have this negative I multiplying everything in this set of brackets. So we have 6 minus 2i. Okay, so we do the multiplication. You have -4 and 6 there. When you multiply them, you're getting -24. -4 and -2i, you're getting +8i. Then you have -i times 6, you're getting -6i. Then -i times -2i, this is going to give you -2 as the answer. Okay, so here's just a matter of simplifying the expression here. So we have -24, we put the like terms together, have -24 and -2 there. Then you also have +8i and -6i. So you have +8i and -6i. So when you add these two here, you're getting -26. Then you add these two, you're getting +2i. Okay, so this is what you have as the solution. All right, so you're going to do part B and part C as your exercise. All right, so thank you very much for attending tonight's lesson. I believe you don't have questions. Yeah, but if you have any questions from what I've been solving from the time we started, you can ask before I end the meeting. All right, okay.
Yeah, hello.
All right, sir. All right, so
Hello.
see,
Yeah, I don't.
oh, you have a question?
No, it's something away from the topics you have
Oh, it's
covered,
about
but
the
just a concern. Just a concern on the assignment. I don't
assignment.
know how far.
Oh,
Yeah.
the assignment I'm done. I'm just remaining with 3 questions.
All right.
So if
Thank
I
you.
not manage to send it today, then I'll send it tomorrow morning.
All right. All
I'm
right.
just remaining with 3 questions. I'm actually in question 4.
All right.
Yes. If I'll not send it today, then expect it tomorrow morning.
Okay.
All right. Thank you very much for attending tonight's lesson. See you in the next lesson. Shalom, shalom.